Today we will see solved examples on substitution method. The first one is integration of cot of log x upon x. Now here, what is the function or which is the function whose derivative is present in the integral? So log x and its derivative is 1 upon x. So we have to put log x is equal to t. So we get 1 upon x dx is dt. So 1 upon x dx, 1 upon x dx will be replaced by dt, and this log x by t, you will get the integration of cot t dt, and integration of cot of t is log of sine t plus c. So what is t? T is log x. So we have to back substitute it in the integral. So log of sine of log x plus c is the integration of this function. Now look at this function cos of root x. Now cos of root x is a composite function. You can think of that way also. We cannot integrate the composite function directly. We don't have any formula. So we have to simplify the composite function to get the standard function. So I have to put root x is equal to t. So put root x is equal to t. So you get 1 upon 2 root x dx is equal to dt. So 1 upon root x dx is equal to 2 dt. So all values will put in this integral and you will get I is equal to 2 integral of cos t dt. 2 times this integral of cos t is sin t plus c. But what is t? T is root x. So I will put it again. So I is equal to sin root x plus c. A third example, sec raised to 8x upon cosec x dx. So what we will do? We will write it this sec raised to 8x as sec raised to 7x into sec x into 1 by cosec x. So sec raised to 7x into 1 upon cos x into sin x dx. Okay, so I will put this now use sec raised to 7x into tan x, but again I have to taken out one sec x. So this sec raised to 7 becomes sec raised to 6x into sec x tan x. Okay, then we will substitute sec x is equal to t as its derivative sec x into tan x is present in the integral. So that will be replaced by dt and you will get t raised to 6 dt. Its integral is t raised to 7 upon 7 plus c. But what is the value of t? Sec x. So again we will put it, that value sec raised to 7x upon 7 plus c is the integral of the given function. The fourth example is integration of 1 upon x plus root x dx. So let I is equal to integration of 1 upon x plus root x dx. So you can take root x common, or this I can write this x as root x into root x, or I can write this x as root x bracket square. Then I can take root x common. So I will get this step. So in this, put root x plus 1 is equal to t. Once you put this root x is plus 1 is equal to t, then its differential is 1 upon 2 root x dx is equal to dt. This 2 will go to that side and you will get 1 upon root x dx is equal to 2 dt. So this 1 upon root x and dx will replace by this 2 dt. And this is our t. So 1 upon the integral becomes 1 upon t 2 times dt. So I is equal to 2 into integral of 1 upon t dt. Its integral is log of t plus c. But what is t? Again, t is root x plus 1. So we will put that value in this integral. You will get 2 times log of root x plus 1 plus c. This is the integral of the given function. Now, phi raised to x into phi raised to x dx. Okay, so let I is equal to the given integral. Put phi raised to x is equal to t. So its differential is 5 raised to x log of 5 dx is equal to dt. So keep this 5 raised to x and dx one side and this divide both the sides by log of 5. So you'll get this equation. Now put those values in this integral, you will get integration 5 raised to t into 1 upon log of 5 dt. 1 upon log of 5 is a constant, so we can take outside. So what is remaining? Integration of 5 raised to t into dt. So 5 raised to t, its integral is 5 raised to t upon log of 5 plus c. So after simplifying, we'll get 1 upon log of 5 bracket square into 5 raised to 5 raised to x, because this t is nothing but 5 raised to x. The next example is integration of 1 upon 1 plus e raised to minus x dx. So I is equal to integral of 1 upon 1 plus e raised to minus x. You can simplify this and you will get 1 upon uh, e raised to x upon e raised to x plus 1. Or you can, instead of doing like this, I can do it like this, multiply numerator and denominator by e raised to x only. If you multiply denominator and numerator by e raised to x, you will get e raised to x upon e raised to x into 1 plus e raised to x into e raised to minus x. So that becomes 1. So here uh, d by dx of e raised to x plus 1 is equal to e raised to x. So this term is in the form of f dash of x upon f of x. And what is the formula to find the integral of f dash of x upon f of x? You know, it is log of the denominator. So we can use that formula. I will get the integral log of e raised to x plus 1 plus c. The seventh example is e raised to x in bracket 1 plus x upon cos of x e raised to x dx. So I is equal to e raised to x into 1 plus x upon cos of x e raised to x dx. So put x e raised to x is equal to t, differentiating with respect to x, but we get x into e raised to x, x as it is derivative of e raised to x plus e raised to x as is derivative of y, x is 1 into dx is equal to dt. So e raised to x into 1 plus x dx is dt, which is our numerator. So numerator will be replaced by only dt, and in the denominator we will get cos of t. So its reciprocal is sec t, and its integral is log of sec t plus tan t. But what is t? T is x e raised to x. So put that value. I is equal to log of sec x e raised to x plus tan of x e raised to x plus c. Eighth example, integral of 1 upon 3x plus 7x raised to minus n. So how to simplify this? Multiply numerator and denominator by x raised to minus n, or x raised to plus n, x raised to plus n, or you can take this minus n to the denominator and then simplify, take it to the numerator. In both the cases, you will reach the step x raised to n upon 3 times x raised to n plus 1 plus 7 into dx. Now here we will put x raised to n plus 1 is equal to t, or we can replace total denominator by t. So 3x raised to n plus 1 plus 7 is equal to t. Differentiate this, you will get 3 times n plus 1 raised into x raised to n times dx is equal to dt. So x raised to n into dx is 1 upon 3 times n plus 1 dt. So this numerator will replace by 1 upon 3 times n plus 1. So the new integral is 1 upon 3 times n plus 1 into integration of 1 upon t, but its integral is log of t. But what is t? T is 3 times x raised to n plus 1 plus 7. This is the integral of the given function. Next is 3x plus 2 root x minus 4 dx. So we will express this linear factor 3x plus 2 with the help of this x minus 4. So put x minus 4 is equal to t. So x is equal to 4 plus t. So its dx, differential of this equation is dx is equal to dt. So put this x is equal to 4 plus t in this equation. You will 3 times 4 plus t plus 2 root t dt. So its integral. So take multiply this 3 to this factor 4 plus t. 3 into 4 is 12. 12 plus 2 is 14. 3 into t is 3t. Okay, and then this root t means t raised to half. Then we will multiply this bracket by t raised to half. So 14 into t raised to half plus 3 into t raised to 1 plus 1 by 2 is 3 by 2. Now take the integral, separate integral on both the sides. You will get t raised to 3 by 2 upon 3 by 2 plus 3 into t raised to 5 by 2 upon 5 by 2. After simplifying, you will get the integral 28 upon 3 times x minus 4 raised to 3 by 2 plus 6 upon 5 into x minus 4 raised to 3 5 by 2 plus c, because the value of t is x minus 4. We have substituted it in the again in the integral. Now sine of x plus a upon cos of x minus b is the integral that we have to find out. So what we will do, we have to here add and subtract b in the numerator. So sine of x minus b plus a plus b. So what we did here, so v plus b and at the same time b minus b, so that they will cancel each other and I will get x plus a only. Now sine of a plus b, you have to use the formula sine alpha plus beta. It is sine alpha cos beta plus cos alpha sine beta. Sine a cos b plus cos a sine b. Then we will divide this numerator by this denominator. You will get this term. Then sine of x minus b upon cos of x minus b is tan x minus b, and cos of x minus b and this cos x minus b will cancel to each other and we will only sine a plus b. Take the separate integral on both the sides. So this is cos a plus b is a constant, so we can keep it as it is. This integral of tan of x minus b is log of sec of x minus b plus this sine of a plus b is a constant and integral of this dx is x. So this is the integral of the given function. Now look at this function e raised to x plus 1 upon e raised to x minus 1. So we will create a denominator in the numerator by adding subtracting 1 plus 1 minus 1. So we get this. Then what we will do, we will divide this this first factor e raised to x minus 1 by e raised to x minus 1 plus 2 upon e raised to x minus 1. This will cancel to each other and we will get only 1 dx plus 2 times this. So it's one integral of 1 is x plus what is the integral of this. So here we will adjust one term, multiply, divide by e raised to minus x. So you will get minus e raised to minus x upon 1 minus e raised to minus x. So if you take the derivative of the denominator, you will get e raised to minus x. So this integral is in the form of f dash of x upon f of x. So its integral is log of f of x. Okay, so log of f of x here. You can directly use f dash of x upon f of x, or you have the choice to substitution method. 1 minus e raised to minus x, put 1 minus e raised to minus x is t, send differential, you will get minus of e raised to minus x into minus 1 dx is dt. So e raised to minus x dx is dt. So we will replace this numerator by only dt, and in denominator we will get t. So integral of 1 upon t dt, and its integral is log of t. But what is t? Again, t is 1 minus e raised to minus x. So you can use the corollary or you can use the substitution simplification method to evaluate this integral. Now look at this example, 1 upon 1 minus tan x. Now this tan x we can write it as sin x upon cos x. So after simplification you will get this expression as cos x upon cos x minus sin x. Okay, so this expression is in the form of the standard integral a sin x plus b cos x upon c sin x plus d cos x. Okay, so for this such type of integrals, uh, we have the choice of simplification. How you can use numerator is equal to lambda times denominator plus d times derivative of the denominator, or you can adjust the denominator by simplifying it in the alpha, so sin of alpha plus beta or cos of alpha plus beta, or sin alpha minus beta or cos alpha minus beta, any one of the formula. So here this cos of x into minus sin of cos x minus sin x can be written as root 2 into 1 by root 2 cos x minus 1 by root 2 sin x. Okay, now for this 1 by root 2 and this 1 by root 2, I will use cos pi by 4 in sin pi by 4. Okay, so cos a cos b minus sin a sin b. Okay, so what we will do, cos a cos b minus sin a sin b, cos of a plus b. Now the derivative of cos is minus sin. Now we will put x plus pi by 4 is equal to t in this integral. You will get tx is equal to t minus pi by 4. So differentiating with, we get dx is equal to dt. And what will be our integral? New integral 1 by root 2 times cos of t minus pi by 4 upon cos t dt. So use cos a cos b, cos of a minus b formula, cos a cos b plus sin a sin b. So now divide numerator by cos t. You will get 1 by root 2 times integral of 1 by root 2 plus 1 by root 2 tan t dt. So what we will do? The integral of 1 by root 2 is t. T upon 1 by root 2, t by root 2 plus 1 by root 2 as it is. This log of tan t, its integral is log of sec t. So this 1 by root 2 into 1 by root 2 is 1 by 2 because we have taken it common from this both these terms. And what is t? T is x plus pi by 4. So put that value here and sec of x plus pi by 4. So this is the integral of the given function. This is one way, but the other way is more simpler than this. In that case, it is we express the numerator as, I will write here. In that case, we express numerator as a times denominator plus b times derivative of the denominator. If you write the numerator in this form, it is very simple to evaluate the integral. This is the standard integral. Now look at this. A cos x plus b sin x upon a cos x plus d sin x dx. Here express the numerator as, numerator lambda times denominator plus mu times derivative of the denominator. Why we are expressing the numerator like this? Because when we expressed our numerator in this form, after dividing the numerator by the denominator, here the denominator will cancel and here, so here the denominator cancel and you will get only lambda and its integral is lambda x. Here the function is in the form of f dash of x upon f of x, so its integral is mu times log of the denominator. So no need to simplification and we will get the answer easily. Okay, now we will stop here.